Hello, and here I have a electroscope, and this electroscope I made out of an aluminum ball attached to a metal rod, which is made out of a metal coat hanger, and it's held down with some electrical tape, which goes into a plastic container, and inside we have a paper clip attached to the metal piece, and two paper leaves attached to the paper clip. And these two paper leaves have graphite on them, and graphite is a good conductor. Keep that in mind for later. So, basically how this electroscope works is you have to have an insulator of some sort, something that can hold a negative charge. So basically, you would build up the charge of this balloon I have here, and I have a wool blanket which holds a lot of charge, and it's easy to build up charge. So we just switch it around in here, and the balloon should be very charged up. And I'm gonna measure how far away the balloon is and when the leaves start moving. Okay, so at about 3 centimeters away from the aluminum ball, the leaves are at its mass extension point. So basically they're farthest away from each other. So the closer the balloon gets, the farther the leaves get. This is because of induction. And induction is where you have a negatively charged thing, insulator, and as it gets closer to conductive material, the negatively charged electrons in it repel. So they go down here and into the leaves, and they also repel from each leaf because the leaves are mobile, so they can move. So the leaves repel each other. So as the balloon gets closer, the leaves repel. Okay, and now I have some leaves with more graphite and leaves with less graphite, and we're going to change the variable and see if that changes anything. Okay, I'm going to charge up the balloon again, which by the way is charging up through friction. Okay, now we're going to see the static electricity, measure it again. Oh, actually, one of the leaves, graphite leaves, is not facing, the graphite sides are not facing each other. So I'm just going to change that real quick. Some human error. Okay, there we go. There we go. Charge up the balloon again. And see. Okay, so the closer the balloon gets. And I think it's actually farther away this time. I think that's because since there's more graphite, it conducts more electrons. So the more electrons it has, then obviously the farther away they can repel from each other. So that's neat. So now, lastly, I'm going to try out the leaves with less graphite to see how that works out. And make sure the graphite sides are facing each other once again. Like so. Let me place it back in. Like that. Wait till it stops moving. Charge up the balloon again to make sure it always has a lot of electrons on it. And then, now we're going to measure it one last time and see. Okay, it looks like they are getting pretty far apart, but I don't think as far apart as with the leaves with a lot of graphite. So I think that's because the less electrons you have, because there's less graphite, so it conducts less electrons, so they repel less. So basically, yeah, this is the electroscope, and this is how it works. Thank you.